So now we'll take one more example for the load calculation. Here in this example we can see we have a UDL which is distributed in 2 meter length. The load of the UDL is 10 kilonewton per meter. Okay, and at point B there is load which is 10 kilonewton, which is 1 meter apart, and this is also 1 meter. Okay, here at point E there is 20 kilonewton located at this point. Okay, so we have to calculate the reaction acting at this beam. Okay, first we will draw the free body diagram. So here we can see the load is acting at this point, 10 kilonewton load. So we can shift this load to the point B. Okay, so we can, same way we can shift this load to the point B, and this will also cause, this is like this situation. Okay, P and P, the distance between the load is A. So this will cause a moment of amount P into A. So this load which is of amount 10 kilonewton will also give a moment. Okay, so load into the perpendicular distance, that is 1 meter, will give us the moment. Okay, so the moment direction will be clockwise. Okay, this will give us a moment of amount 10 kilonewton meter in clockwise direction. Okay, so we have resolved this portion. Now we'll come to this UDL. Now we know the UDL will be concentrated at the midpoint of the beam. So midpoint will be 1 meter. Okay, 1 meter. The amount will be 10 into L, 10 W into L. L is 2. So 20 kilonewton load will be acting concentrated at the midpoint of this beam. Okay, so we have resolved the UDL also. Now we will come to the point E. So we'll shift this load to point E, and that is 20 kilonewton. So this will also give 20 into 1 meter perpendicular distance will give us a movement. Okay, the movement will be in counterclockwise direction. Okay, the movement will be 20 into 1. So that is 20 kilonewton meter movement in counterclockwise direction. Okay, so we have shifted and taken all the movement also. Now we'll go to the point A. So here we will have one reaction RA, vertical reaction, and one horizontal reaction RAX. Okay, here we will have RF only. So if we draw the free body diagram of the whole beam, that is A, B, C, D, E, and this point is F. So we can see here we have one vertical reaction RA. Point B we have horizontal force of 10 kilonewton and a moment of 10 kilonewton meter. At the midpoint of C and D we have a load of 20 kilonewton. At point E we have a vertical downward force of 1 kilonewton and a moment of 20 kilonewton meter. Okay, at point F we have a vertical reaction of RF. Okay, and here we have a horizontal reaction RAX. Okay, so we have resolved all the forces. So this is called the free body diagram. Okay, now we'll take summation of all horizontal forces equal to 0. So here we have one horizontal force that is in this direction and one reaction. Okay, horizontal reaction. So RAX plus 10 is equal to 0. So RAX is equal to minus 10. So this means the assumed direction of the reaction is wrong. We'll take the reaction in this direction. The reaction will be, horizontal reaction will be in this direction. Okay, the negative sign shows this. So So RAX comes out to be 10 kilonewton in this direction. Clear? Now we'll come to the vertical forces. Summation of all vertical forces is equal to 0. So we have RA upward, okay, and RF upward, and this 20 in downward, and this 20 is also in downward direction, that is equal to 0. Clear? So from here we'll get RA plus RF, that is equal to 40. Clear? Now the third equation will take summation of all movement about point A. Okay, again about point A is equal to 0. So we'll take this 20 into the distance 2 plus 2, this is at 1 meter. Okay, so 5, 20 into 5, that is in clockwise, plus this 20 into this is 2, 4, 6, and this is 8, 20 into 8. Okay, and next RF minus this is counterclockwise, RF into 10. Okay, RF into 20. This is also a movement, this is in clockwise, so positive 10. This is counterclockwise, that is minus 20 is equal to 0. Clear? So this will give us 100 plus 160 minus 10 RF plus 10 minus 20 is equal to 0. So from here we will get this 260 minus 10 RF is equal to 0. So this is 250, that is equal to 10 RF. So from here we'll get RF is equal to 25 kilonewton. Clear? So we'll put this in this equation. So we'll get RA. So RA will be equal to 40 minus RF, that is 25. So this will give us 15 kilonewton. RA will be 15 kilonewton. Okay. So this is how we'll calculate all the reaction. So for calculating the bending moment or shear force diagram, the first step is to calculate the reaction at all the points. Okay. The vertical reaction and the movements at all the points we have to calculate. Clear? So this was the solution for this.